All right, so we're going to talk about chapter 2 here, and chapter 2 is going to just describe lots of characteristics of the Earth and even the sun and some things like that. So this is 60 slides, so we're going to have to kind of skim a little bit. So first thing you need to do is take out your note sheet that I gave you in class and go to the chapter 2 section. Like I said, because I'm going to hit the highlights, you might need to pause this at some point and fill in the blanks. You'll see a lot of the information on the slides, even though if I don't say it. Like I said, I'm going to hit the highlights, or you can get directly into the slides and go through it that way. But don't want to leave gaps in your notes. So with that being said, let's jump right in, and I'm going to try to hit the highlights in 15 minutes or less of chapter 2. So first thing we need to realize is that the Earth is a part of the solar system. We should know that. We're not going to talk too much about the solar system, but Earth's placement in the solar system makes it perfect for life to exist. Any closer to the sun, it'd be too hot. Any further away, it'd be too cold. Like Mars is a little bit further from the sun than we are, and so that makes drastic temperature changes in Mars. There's evidence that maybe life could have been supported at one time on Mars. They're looking for water, things like that, but Earth just has that proper balance of heat, of light, that makes it so things can grow. Very fascinating that is the case with the solar system. We know that the Earth revolves around the sun, so it is both turning on its axis and it is orbiting the Earth, or orbiting the sun, sorry. And so that there is a rotation that is happening, and then there's a revolution that's happening as it's going around the sun. So as it goes around the sun, that makes a year. As it's rotating each day, that makes a day, right? 24 hours. It's not a perfect 365 days, and that's why we have a leap year every 4 years. So just some things. The Earth is also kind of like if you've ever taken apart a baseball or another type of ball, like a golf ball. There are different elements, different layers to that. So we have like the inner core and the outer core, the mantle and the crust, different layers that exist. And there's a lot of things that are going on underneath the surface of the Earth that affect what we see at the surface. And we'll get to that later on when we talk about tectonic plates. We have the atmosphere, which is super important, and that is 98% of the Earth's atmosphere is within 16 miles of the surface. We kind of rely on that atmosphere, again, as a way of supporting life. So just kind of realizing that there's kind of layers even above the Earth, the hydrosphere, the lithosphere, important things to keep in mind there as well. Like I said, some slides I'm going to skip past a little bit. We have seasons. Now, one of the things I think is important is that we will talk both about northern and southern hemisphere, but their seasons are opposite of one another. So when it is summertime, as it is right now in Indiana, in some place like New Zealand or Australia, is going through cooler months of winter because of how the Earth is tilted. The Earth is either tilted towards the sun or away from the sun, depending on what hemisphere you are in. So just kind of an interesting thing. Now, some places like Australia wouldn't necessarily have a winter like we would think of because of its proximity to the equator, but the seasons are opposite of each other. Good example of this, Antarctica, extremely cold in the wintertime, right? If people visit Antarctica, scientists and things like that, most of the time they are going in the summer, which is like November to February in Antarctica's time frame. Not when you would think. You would think they'd go in July and August, but that's actually their winter. So interesting how that works. The poles are the extremes of the Earth, right? They're going to be tilted towards the Earth, towards the sun, or away from the sun. And so we talk about these terms of the solstice, which is their summer solstice is the first day of summer. It's also the longest day of summer. So usually around the end of June. It's always around the end of June, but June 21st is the date listed here. It can be slightly flexible with that. It's not always directly on the 21st. And then around December 22nd is the winter solstice, which is the shortest day, which means you have the least amount of daylight. So I think that's always interesting because I always think like January and February, it feels like we just don't have much daylight, but technically December 22nd is the least amount of daylight that we experience because of the winter solstice. We also have the equinox, which was whenever the length of day and night are equal. And so there's 12 hours of both of those. So those occur on September 23rd and March 21st. And that all, again, has to do with the tilt of the Earth and its revolution around the sun. We talk a lot about the equator in here because it breaks the Earth into northern and southern hemispheres. And things that exist around the equator are usually tropical, hot and sunny. One of the terms that I often tell students to remember is consistent. Temperatures around the equator are not going to fluctuate. You're not going to experience a winter or a summer. Temperatures are going to be more summer-like all the time. Elevation can have an effect on that. This picture right here, I believe, is Mount Kilimanjaro in Africa. Africa does not really experience snow, but notice that there is snow at the top of that mountain. It's a dormant volcano. Because it is higher in elevation, it creates colder temperatures. So there's snow often on that mountain. Moving on here. Wind and water currents affect temperature as well. If you live in kind of northern Indiana, they talk a lot about lake effect snow. So cold air moving down from Canada moves across the Great Lakes, and that causes more snow to fall in places like Chicago than it does here. And we're only a few hours from there. So we get warm and cool temperatures mainly because of what's kind of happening around us because of those currents. And the rest of the world's kind of the same way. So there is a difference between weather and climate. Weather is kind of what's happening at a given time. So we walk outside, it's raining, it's sunny, it's cloudy. That's the weather for the day. But climate is the average weather conditions over a long period of time. So, we kind of know the climate of Indiana, that we have a winter and we have a summer, but that the weather may be different on any day. We know we have cool days, we have warm days. So climate and weather are not the same thing. The weather causes the climate to be what it is over a long period of time. Like I said, a couple of slides I just have to kind of move past. We talk about water. Water is the precipitation either coming in rainfall or snowfall. You probably don't think of snowfall as precipitation. I used to live in Montana for a little while, and I know farmers and lots of people depended on the snowfall to create a snowpack that when it melted in the spring, it caused water to kind of flow out of the mountain and down so that they could irrigate. So you might think, oh, well, snowfall wouldn't really be that important in the growing seasons, but it actually is, depending on where you're at. If water is in short supply, and it was where I lived in Montana, then that can be something that snowfall is an important part of precipitation. But there's also hail, sleet, and other things that form all the moisture that's falling. Landforms are important here. This kind of shows what can happen with a rain shadow. Something talked about, I believe, in chapter 1, but it's kind of mentioned here again. And that's whenever water is picked up over the ocean, kind of similar to the lake effect snow that I was just talking about. Then all of that cool air condenses and is dropped on one side of the mountains, where on the other side of the mountains is very, very dry. A good example of this, if you've ever heard of Seattle, Washington, lots of rainfall. People say that there's super cloudy days all the time. It rains constantly. Everything's green. But there is the Cascade Mountains that are near there. And if you just go on the other side of the Cascade Mountains for miles and miles and miles, it is very, very dry, very desert-like. Much of central Washington is not like the western coast of Washington because of the rain shadow. So even mountains can affect rainfall. It's something that we don't deal with a lot here in Indiana because of, we don't have mountains. We're going to talk about climate zones now. This is definitely in your notes. There are these different climate zones here, 6 of them mentioned. And there's also other ones that it gets really confusing. There's humid subtropical, but kind of the main categories here are tropical, which we've all heard of before, rainy, humid. Then there's desert. Very, very dry. Even places that are cold can be a desert. Antarctica is a cold desert. How is that a desert? There's no sand there. Well, it's not really defined by sand. It's defined by the amount of precipitation. And even snow does not fall on Antarctica very, very much. All the snow that accumulates, though, pretty much stays. And there's tons and tons of ice that can never melt. So that's really what we see when we see the surface of Antarctica. It's not snow that is, fallen. It may only get, a couple of inches of snow a year. And 14 inches or less of any precipitation, I believe that's the number, is classified as a desert. So we also have humid temperate and cold temperate. This is kind of getting into more what we'd experience in Indiana. Polar is much, much colder. Northern areas, northern parts of Canada, Russia, you're getting into kind of more of that polar climate. High mountain, obviously, is exactly what it sounds like, where we see the differences when you're higher up in the mountains. So each climate zone is different, supports different life that exists there. So one of the things we acknowledge here is that the climate is changing. There's a lot of talk about why this occurs. Obviously humans are having an impact on this, fossil fuel burning, and just the depletion of the ozone layer. But there has just been this trend that scientists have been able to track where the Earth is warming. It's not cooling, and obviously we kind of have to be aware of that. So human activity has influenced climate change, and that can lead to more extremes. I know we have some warm days, and people will be like, "Oh, climate change, it's a real thing." We're going to have those fluctuations in temperature anyway, but it does seem that there is this trend of warming temperatures that has happened here on Earth. There's some videos here that you could totally access later on and watch those. We're not going to go over those now. So we're going to jump into the second section of this chapter. And this kind of talks a little bit more. We get into tectonic plates, volcanoes, earthquakes, and then some other things that are affecting the Earth. So the Earth has a crust that we've already talked about earlier, and it's made up of these plates that move very slowly. But as those plates kind of brush against each other and push against each other, there's these different faults that are formed, and that creates some of the ways that mountains are formed, but also the fact that we can have volcanoes and earthquakes. So that's all happening under the surface of the Earth. There's even fault lines that run through Indiana. I can think of only one earthquake that I've experienced. That was back in 2003 or 2004. I experienced a little bit of an earthquake. It was just a slight shaking. Didn't really know what was going on, but someone like someplace in California would experience a lot more earthquakes than that. Mainly, it's on a future slide here. This one kind of shows it. But notice how there's so much red over here on the western coast of the United States. And so they experience a lot more earthquakes there. That's also where there's a lot of dormant volcanoes and other geological activity. If you've ever been to Yellowstone and maybe saw the geysers that are out there, that's part of geological activity. But then there's Mount Rainier in Washington and Mount Hood. Those are both dormant volcanoes. And part of that leads to this next slide, is that the western coast of the United States, all the way down the western side of South America, and then over on the eastern part of Asia, and then down kind of around Australia here. This forms what's called the Ring of Fire. And it's not really a ring, it's almost more of a horseshoe. It's kind of in-shaped, and this is kind of like the location of most of this geological activity, these tectonic plates affecting volcanoes and earthquakes. That's where we're going to experience that. You can notice that Hawaii, which is over here, Hawaii would be located in the Ring of Fire, and lots of people visit Kilauea and the other volcanoes that are in Hawaii. In some of the parts of the world, Asia specifically, we talk about tsunamis. Tsunamis are formed by those shifting tectonic plates under the ocean, which can cause these massive tidal waves, extremely destructive. There have been some, even in recent kind of history, maybe you've heard of some of the tsunamis that have hit Asia. We also have other things affecting the Earth besides earthquakes and volcanoes and things like that. We have weathering that's happening. Much of what we see kind of like in the Grand Canyon, even rock formations around here in Indiana, you can see the layers of limestone and how they've weathered over time. all that is kind of affected by weathering, which can be caused by wind, by rain. McCormick's Creek State Park, close by to us, the waterfall there was formed by the weathering of the water pushing through there and forming that canyon. All the way from the period of the Ice Age all the way up till now, those rocks are still getting affected by the water that flows. Erosion is an effect where the soil kind of gives way because of rain and water, and that's going to be a big problem for like farming. So erosion is something that we have to kind of know about. And we're getting closer to the end here. The buildup of materials creates landforms such as beaches, islands, and plains. You can see some very unique types of landforms. I was in Wisconsin over the summer and I saw one of the only 5 limestone beaches in the world. And so it had all these little limestone smooth rocks, but you can't find those. But that's affected by, over time, things happened on the earth to cause a very unique kind of landform to develop in that area. Human activities also have an effect on that. So when we mine, we build canals. Indiana had the Erie Canal that ran through other states as well. We're affecting the environment anytime we do those things. They may be necessary, but we are changing the environment at a faster rate than ever before because there's constantly new developments. Mining is needed for fossil fuels. So we just have to be kind of aware of those things. And hopefully that kind of leads us to more of a management and conservation of our resources. Lesson 3 here, try to go fairly quick to finish this up. Elevation describes how far above the earth you are. And if I can move this out of the way, you can see this. This one doesn't show up very well. Maybe it's on the next slide. Earth is pretty fascinating in the fact that like Mount Everest is the highest place on Earth. But we also have the Mariana Trench located in the ocean, which is actually deeper than Mount Everest is tall. So if you could like pick Mount Everest up and put it in the ocean, the top of it would not stick out. So we have a lot of extreme landforms that are created. And so this talks about, we have valleys and plains. A lot of that stuff exists in Indiana. We have plains. The Ice Age, when it came through, the glaciers kind of flattened out everything. But then you get to like the Colorado Rockies and see the mountains out there. And the glaciers never receded that much to cause the land to be flat plains. Continents are the largest land masses on Earth, and we also have islands. Australia is kind of the weird one in that like it looks like an island because it's such a large landmass. We as geographers classify that as a continent. We'll talk about peninsulas that are formed. That's when it's surrounded by water on 3 sides. So just some different terminology that's all affected. So here is a picture of Australia, but this is a continent. Let's get past some of these slides here. And this is referring to Central America. I believe, go back here, is that narrow strip. It's an isthmus. So just a physical picture of what that looks like. That's an isthmus. This is what I was talking about, the Mariana Trench. So it's 36,000 feet deep. Mount Everest is only like 29,000 feet only like 29,000 feet tall. So just definitely a lot of extremes that exist. Even in the ocean, lots of the areas have not been explored. This is something we're going to do an activity in class on, but just that the Earth is 97% water. Kind of really, when you look at a map, you see a lot of blue, right? Only 3% of that water is fresh water, but like 2% of that is locked away in glaciers, in the ice caps, all that kind of stuff. We can't access that. Only 1% of fresh water is drinkable. So this kind of shows that in this diagram. We're going to look at this a little bit more, and it's also in the choice board activity that we're doing. So that's a big deal because not everybody has access to clean water. Out of all these droplets, only that one right there is fresh water that we need. Salt water now can go through processes like desalination, so we can purify it. We see a girl here, this is in Africa, pumping water from a well. It doesn't look like a typical well, right? Like it's homemade. And in places where they just don't have access to water, wells have to be dug. Those wells can dry up very easily. They're still using some fairly primitive methods to access water, and so it's kind of a big deal. We'll talk about that more in Africa. We kind of underestimate just how precious water is and how it is a limited resource in a lot of places. So the world's largest bodies are oceans. That should not surprise us too much. And just not every place has access to to fresh water. So lakes, rivers, and streams also that's kind of where we're getting most of that fresh water from. There's also like aquifers where water is underground, and that's the reason we have those wells. Some pictures here of bodies of water. We obviously use it for recreation, but water is a resource that we depend on constantly. We don't talk too much about the water cycle. It's more of a science concept. We have this water cycle of precipitation falling, and then it evaporates from the oceans, from lakes, and it goes back up in the atmosphere, and then it rains, and that cycle just repeats over and over and over again. So that's what's being shown in this little diagram right here. Humans' actions are affecting the water supply, toxic waste going in there. So chemicals and all those things affect that. There's acid rain that happens, which is also from the burning of fossil fuels. So water is precious, it's limited, and we need to make sure that we are conserving that. So that's just kind of a quick overview of chapter 2. Definitely this is kind of idea of water and the seasons. And just how the earth is moving, I think, are kind of like the big concepts of the chapter. So we'll do some activities in class and in the choice board that relate to those. Thank you for watching.